we are given the point A, 3, 4. This point is the right angle vertex of an isosceles right triangle. The hypotenuse lies on the line y equals -2 times x plus 15. And we want to find the coordinates of points B and C. So first, let us slow down and look at the geometry. Because the hypotenuse lies on that line, both B and C must lie on the same line. And because the triangle is isosceles and right, the two legs, AB and AC, must have equal length. So the two unknown points are constrained both by the line and by the symmetry of the triangle. In method 1, we describe both unknown points directly on the line. So we first write them in the general form, b equals xb, yb, and c equals xc, yc. Then, because both points lie on the line, y equals -2x plus 15, we can replace yb and yc. That gives b equals xb, -2xb plus 15, and c equals xc, -2xc plus 15. Then we use the condition ab squared equals ac squared. After simplifying, we get the relation xb plus xc equals 10. So the two x coordinates must balance around the value 5. Next, we rewrite the line BC in general form as 2x plus y minus 15 equals 0. Now we can use the formula for the distance from a point to a line. That is where the height h comes from. So h is the distance from point A to the line BC, and that distance is square root of 5. Then we compare the area of the triangle in two different ways. This gives xb equals 4, and then xc equals 6. So the first method gives b equals 4, 7, and c equals 6, 3. Now let us see the same answer appear geometrically. Method 2 is more geometric. We draw the perpendicular from A to the hypotenuse and find its intersection point S. That midpoint is 5, 5. Now we draw the circle centered at S with radius square root of 5. This circle passes through A, B, and C because in a right triangle the circumcenter is the midpoint of the hypotenuse. So the midpoint S is equally distant from B and C, and because we chose the radius to be SA, the same circle also passes through A. Next, we substitute y equals 1/2 x plus 5/2 into the equation of the circle. That gives a quadratic equation in x. Then we factor it into the form x minus 4 times x minus 6 equals 0. So x equals 4 or x equals 6. Its intersections with the line recover exactly the same two endpoints. So the geometry confirms what the algebra already told us. Method 3 is the shortest. Here we use the fact that the green segment is perpendicular to the hypotenuse and meets it exactly at its midpoint. And from the circle, we already know that SA, SB, and SC must have the same length. So once we know the vector from A to S is 2, 1, a perpendicular direction is 1, -2. From S, we use that perpendicular vector in opposite directions. That immediately gives B equals 4, 7 and C equals 6, 3. So algebra, geometry, and vectors all lead to the same answer. The coordinates are B equals 4, 7 and C equals 6, 3. And that is the full picture. One problem, 3 methods, one final answer.